Hi there, Christoph here. Today we're going to go over some system of equations and system of inequalities to essentially show you how quickly you can fulfill these types of problems in any problem that you do in your classwork. So the first thing we want to always consider is that when we're doing algebra, we have to consider what we're looking at, in this case, a linear equation. The best way to identify one of these linear equations is to always consider what is the exponent of each one of these x values. Well, if you really take a close look, it's an invisible 1 here and here, which basically means it's to the first power, and we can normally ignore the number itself, but it's a good kind of placeholder for us to understand where we are currently, and we are currently drawing lines. So in order for us to begin, we're always going to bring out our y equals mx plus b form to understand where our numbers are and what they reference us to as far as the b and the m. We should know that m is our slope, which is a reference to a rise over run, and y is our y-intercept, or the way I like to think of it as the starting point. You need to know where to begin before you start moving, the rising and the running. So y is always going to be the first thing we identify so we can basically get ourselves starting to move. So from here, we'll go with the first equation. For this one, our y-intercept is 2. So if we're going to start at 2 for our red line here, we can essentially consider that is the y-intercept, that is the location of our dot. We also want to basically keep in mind that anytime we do consider y-intercepts, it's going to be a 0 for our x, and then the 2 is the actual value that we will see in our equation. So 0 should always be the x value of any y-intercept that you're observing. A big key to understand this is that if you take a look at the middle line that we are writing our y-intercept dot, and then kind of look around to the left and the right, on the left you're going to have a -1, on the right you're going to have a +1, and then simply ask yourself, what is between -1 and +1? Well, it turns out it is 0, the 0 of x that we have for our y-intercept. So that's always going to be the case, just to make that pretty cleared out. We're going to be repeating that over and over to essentially find our starting points. Once we find our y-intercept, now we're going to increment by our rise over run slope, which is the m value, which is essentially the number 5 in our first equation. Though we look at it and we say, all right, well, we need a rise and a run. We need a fraction. This is where we have to recall a 5 by default doesn't need to be shown, but there is a number underneath it. And that number is 5 over 1, the division of 1. This gives us the run and is normally the default run, including the next problem we'll see right underneath. We can always think of that 1 as our run if it's not visible already as a fraction. So always keeping that in mind helps us understand what the rise and the run will be. So from here, we're going to rise 1, 2, 3, 4, and 5. I kind of didn't create a line all the way up there. And then we're going to run once to the right, assuming that, of course, all of these tick marks are an increment of 1, as so. So starting at 2, moving up 5, well, that gives us on the 7 location for our y-intercept, or our y-axis. And then 1 to the right for our run gives us our final destination for our first or second dot. Now from here, what we need to do is simply connect these two together with a ruler. And voila, the first line of our group here in this system is done. Then we'll go ahead and do the next one. Much faster in this case, because I wouldn't have to explain every single detail again once we've understood it, right? So the first time you do something, there is going to be a challenge for learning it, and then after you've learned it, it's just a pattern that you do over and over again. So in this case, we have a -3 for our y-intercept. That means we go down 3 times. We hit our -3 on the y. And then from there, we're going to take a look at our slope, -2/1, which means we have to adjust for our negative value, which in this case, if rise is the default plus, a negative is going to be a fall, going downwards. So we're going to go down 1, 2, and then that's a +1 underneath as it normally will be, always will be, if it's popping up like that. It's going to be to the right one. And there is our second line value. And from here, a solution is very important here because we're trying to find where these two lines are essentially touching each other, where they cross, right? And we can see that there is a location in space in which they both interact. And this is the -1x and then -2y. This is where the location will be. And as always, we have to make sure that we state the solution as a xy coordinate. So we're going to say solution equals -1 comma -2. And that concludes for this particular case. Now, when we go into inequalities, we're not going far off from this pattern. That's why I'm fitting this whole section here into both inequalities and equations, because we still follow the graphing process. We just have to consider now a little bit of a twist when it comes to the inequality itself. So there's our first problem, and there's our second problem. So for this problem, one of these are actually doing well as far as our matching to our y equals mx plus b. So we have to, again, bring back our mental memory of what it looks like to be a line, and it's a mx plus b situation. For us to continue forward, we have to consider now which one of these two matches a similar structure, where y is going to be available to be by itself, and the other variables, the other bits and pieces of the equation are going to be on the other side of the equation. So if I consider first and foremost that there is a certain relationship between how we apply inequalities and equal signs, they are treated similar in algebraic processes. So anything of this form essentially represents a balancing scale between two sides, one on the left and one on the right. There's your scale. It just kind of means two or multiple different meanings based on each one of those symbols, which we'll go over in a little bit. For the first case scenario, you already know equal sign. Equals is the direct meaning of this is this. So it's a direct relationship. X equals 5, meaning that X is going to be the number 5. With the others, we'll go ahead and take a look as we build these now. So for the first cases, I can already tell you right there, we have a match between these two types of default templates. We have the y equals mx plus b matching the y less than -3/2x plus 2. Now, it's not the same symbol again, but if we treat each one of these signs of the same way, then we can still visually see that there is a pattern there that we're matching. So since it's in our nice and setup, y equals mx plus b linear form, we can start graphing this right away. So I'm going to give it an underline. I'm going to go to our y-intercept first, go up +2 for our y-intercept, and then I'm going to take our slope, the rise over run, and go down 3 times over 2. 1, 2, 3, 1, 2. There's our finalized dot for the second count. And from here, now we got to consider it's not an equal sign, so it's not going to be on the line that we're concerned with. When we think of equal sign, it's everything that the line represents. Every single dot that the line creates makes a full solid line. However, when we're looking at less thans, we got to consider here it's not, in this case, does not have an underline like the less than equal or less greater than equal sign. They essentially have a lack of these two signs. So there is no equivalence here. which means that the way we draw these is more of a ghosted line, where we are not going to actually exist on this line itself, but we're going to exist around the line based on what the inequality is trying to tell us. Here's the trick part. We want to make sure we understand this for all inequalities. Whenever you're done with your actual line, then you can essentially ignore the equation that made up the line. You can kind of just scratch it off in your head and then just call it the line. This is the greatest tip you can do when you're dealing with inequalities. When you say the line, now you have a much straightforward experience. You're saying y is less than the line. That's a specific meaning here. Because now, if we look at our y, which would be our y-axis, the up and down arrow that we see here vertically, and we take a look at where the line is, we know there's a dot here at 2. That is where our intercept was. So we look at our intercept, we look up, and we ask, is this a number bigger or smaller? Well, this will be 3 because it's above. And then we look down, and we say, is the one below it bigger or smaller? Well, that's going to be a 1, rendering it a smaller number. So when I say y is less than the line, now you ask yourself, which one of these two numbers is less than the line? Is it 3 or is it 1? Especially considering that our y-intercept is at 2. Well, it should be 1, right? Because that is a number that is smaller than the intercept itself. So our shading direction is going to be in this downward motion. End of story. All right, what about the next one? The next one's a little messier, so we got to do some algebra to basically organize it a bit. I'm going to go ahead and take this to the side. First and foremost, I'm going to get y by itself. My goal is to essentially get y by itself, and which means I'm going to lock down that y in its color. The rest of them, I'm going to move piece by piece through algebra. So for my 3x, all I have to do here is if I want to move it away from y so that y has a chance to be alone, I will do the opposite. As a grouping, I will subtract both sides by 3x. This will leave me with 2y by itself, a greater than symbol, because now these two will be 0, and we can ignore 0. And then on the other end, we're going to have a negative 3 minus 3x. They cannot combine into a single. They are not like terms, so we keep them separate. That's all we have to do. Sometimes there's no math involved, just rewriting. Finally, if I want to continue on my path to get y by itself, now we take a look at the next thing that's in the way, and it's the 2. So we're working our way further away from y, closer to y, and only sticking to the same side as y. So we were only working on moving stuff away from the left side. Now we're going to be dividing by 2 to do the opposite of what it's trying to do currently. It is trying to multiply with y, so we're going to divide by it to get it out of the way. This would mean we have to do this to all of these particular pieces, all terms involved. Get a divided by 2. Now I can say y greater than equal to negative 3 over 2 minus 3 over 2x. And now we have finalized our line to have y by itself, which lets us draw the next step. All right, so from here, same detail as always. We just had to take a few steps in between to get this format to look nice. From here, I'm going to find my intercept at negative 3, 2, which is a little tricky, but if you really think about it, you can change it into mixed numbers. This would be 1.5. So that means a negative 1.5. We go down 1, and then we go down a half right there. So there's where our y-intercept will be. Sometimes it can get a little tricky, but use those boxes to your advantage. If you know what a 1 is, you know what a half is. You can move in halves as well if necessary. Next, we go with our rise over run. So 3 down and 2 to the right. So from here, I gotta move by big halves, 2 halves at once. So there's our 1 from half to half. 2 from half to half, 3 from half to half. And then we're going to go 2 to the right. 1, 2. And there's the second dot to our graph. Now we're going to connect the dots. Whenever you have 2 points on a graph, you can create yourself a connected dot line. Now for this one, we do have an underline for our inequality. So from here, we do essentially just straight through and get that ordered in, just like so. Now they kind of look parallel in this case, but for this case too, we're going to do the same idea with our inequality. Once we get our line together, we're going to ignore this area as far as equations go, and then say y is greater than the line, which means that we are looking for any number on the y-axis in relation to our y-intercept that's greater than the line or above the line. So we can always think about this factor being about -1/2 as we've understood. This is our -1/2. And anything above it, like a 0, which is right there in the middle, would work as our location. So all we have to do now is shade the top part for the greater than side of our line, like so. And in the end, our actual answer will lie between the two shaded locations. So both of these lines are shaded right there in between each other, and any answer in here is now a reference to a equal, a situation where it will work. So now we got to consider we're not using equal signs, so there is not just a single answer here. Any dot in between these will fit into our equations and actually fulfill the balance of the equation there, or inequality in this case. All right, one more over here. So both of these are now scrambled, so we got to unscramble them. 5x and I'm going to add a 2 to both sides. And then I'm going to divide everything by 2 as I did before to get rid of the number in front of y. So without doing any extra explanation, you're going to notice this is going to work out pretty quickly for us. So 2 over 2 is going to be a 1. That's our y-intercept. And there it is. Then we'll take our rise over run, go up 5, 1, 2, 3, 4, 5, over 2, 1, 2, there it is. Then we do have a underline involved for our inequality. So I'll take those two and connect them with a solid line. Finally, what we want to do is, even though it's flipped, we're now kind of reading it in a backwards direction. Y is greater than the line. You have to consider that the inequality always has the bigger side of itself open to the bigger number or bigger value. So right now, the inequality is trying to eat, essentially trying to eat the y, and the size of this side opening is much larger than the other side. So this is a way we can reference, all right, that means that the right side's greater than the left. So y greater than the line, which means any number above our current location, including this one, as we are at 1 on our y-intercept, we're going to go up to 2, 3, 4. All of those are greater. So then we highlight the top side here. And for the final equation, and we're done. I'm going to subtract x from both sides. I'll keep my negative 3y. Then there's a little trick here, and there's a reason I've added it, because there is a slight difference between equals and inequalities in the way that we actually use and work with them in algebra. The situation where you find yourself multiplying or dividing by a negative number, because we know multiplying or dividing by a negative number flips signs everywhere. We have to compensate another flip that's going to happen. That flip is going to be the sign itself. So this is the only case scenario where you need to make sure you are paying attention to your sign so you can essentially not get fooled by that flip. And that's going to be a negative 1 because we had a positive 3 divided by a negative 3. That makes a negative 1. So it was positive, now it's negative. And that's really the reason for the flip of the sign, because a negative multiplication or division will flip everything around on its head. There we go. Now we're going to go down 1 for our y-intercept. There is a slight interesting issue with our x over 3, but once you realize that's technically 1 times x over 3, which basically means 1 over 3, then our rise over run is still visible to us. It's almost like when we had to add a 1 underneath our fraction. Well, sometimes if we don't visually see that number, we have to think about the fact that there is indeed a number in the front. It's 1. It's multiplied by 1. So we're going to go up 1 to the right 3. There's our next point. And there is no underline for our inequality, so we're going to do a ghost line. Like so. All right. Going to continue this a little bit just to kind of get a clearer vision here. And then finally, y, and this is where your problem could go wrong if you didn't flip the sign because of the negative multiplication or division. So now we have y is less than the line, which means any number underneath, including the negative 2 underneath the negative 1. And finally, our answer is going to lie in the double shaded area between these corners and as it expands into infinity in that direction. So, couple of factors to remember. We want to make sure we always flip signs of inequalities when we're multiplying by negatives and dividing by them as well. And then there are a couple of invisible values we always want to think about. Around any number in space we'll call x, there's a multiplied by 1 in the front, there's a divided by 1 at the bottom, and then there's also a power of 1 in that corner. We don't normally see them, but they are available as a sort of mathematical instinct that we can use anytime we need to use extra details that are not necessarily visible to us. And that's all. That's how you can solve any inequality, just making sure it is in the mx plus b form, and then applying the correct shading based on the y, the inequality, and this phrase, the line, instead of using the full equation to confuse yourself about the details in between. Just focus on that y-axis, the up and down line vertically, and then you'll be able to match some points to make sure that your y is on the right side of that inequality. So thank you for watching. Hope that helped you out, and see you next time.